Exercise 10.2 question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center of the circle. Perpendicular at the point of contact to the tangent to a circle passes through the center of the circle. We are given a circle with the center of xy is a tangent and P is the point of contact, and through P a perpendicular is drawn, and we have to prove that this perpendicular passes through the center of the circle. xy is a tangent to the circle at P. To prove the perpendicular to xy at P will pass through the center O. If the perpendicular at P, if the perpendicular to xy at P doesn't pass through the center O, let it pass through O dash, join O dash P. And we just take the opposite of that statement. If you are to prove that the perpendicular to xy at P passes through the center of the circle, we assume that the perpendicular to xy at P doesn't pass through O, then let it pass through O dash, then join O dash P. Now O dash P is perpendicular to xy, perpendicular to the line xy. O dash P is perpendicular, it is drawn perpendicular to xy. OP is perpendicular to xy. If O is the center of the circle, OP is the radius, so tangent is perpendicular to the radius through the point of contact. It is a theorem. OT perpendicular to PQ. OP is perpendicular to xy and O dash P is perpendicular to xy. I was just copying from the previous page. This is not possible as we cannot draw two perpendiculars to a line at a given point on the line. Only one perpendicular is possible to be drawn at a point on a particular line. Therefore, OP and O dash P coincide. OP and O dash P coincide. So O and O dash coincide. O is the center of the circle and O dash is the point through which the perpendicular at P passes. So O and O dash coincide, they become one. The perpendicular at P passes through the center of the circle O. Hence proved.